Assalamualaikum and good day everyone. Today our group will be presenting a case study on ground subsidence, which is a serious civil engineering issue that can affect infrastructure and public safety. Before going into the case study, let's first understand ground subsidence. Ground subsidence refers to the gradual sinking or sudden collapse of the ground due to the loss of underground support. Common causes include groundwater extraction, underground pipe leakage, soil erosion, heavy urban loading, and also aging infrastructure. This issue is important because it can threaten infrastructure stability and create safety risks in urban areas. Moving to our selected case study. Our case focuses on the sinkhole incident at Jalan, Masjid, India, Kuala Lumpur, which is occurred on 23rd August 2024. Since this happened in a busy commercial area with high pedestrian activity and complex underground infrastructure, it became a major public safety concern. Initially, the area was operating normally with public pedestrian movement. Then a sudden ground collapse occurred without warning. Emergency team responded quickly, the area was secured, and investigation began to assess the situation and plan repair works. This shows how unpredictable underground failure can be in dense urban environments. This incident is more than just a ground collapse. From a safety perspective, it creates an immediate danger to pedestrians and nearby infrastructure. Socially, it disrupts daily activities, traffic, and also nearby businesses. Health risks may also arise from damaged drainage or sewer system. Lastly, it raises legal and regulatory concerns regarding maintenance, responsibility, and also infrastructure safety. Overall, this incident highlights the importance of proactive engineering risk management.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Habib. Will now be proceed on the cost and engineering explanation of the Jalan Masjid India incident. First, the geological foundation of the Kuala Lumpur karst. Rainwater, which is naturally slightly acidic, infiltrates the ground and reacts with the calcium carbonate in the limestone, creating underground cavities and pinnacles as shown in the picture. These cavities can exist for years without surface symptoms, especially in urban areas where concrete and asphalt hide the gradual migration of soil into the rock fissures. So, the trigger mechanism. In urban centers like Kuala Lumpur, leaking water pipes and aging drainage systems are frequent triggers. Maintaining underground utilities is more sustainable than emergency repairs and disaster recovery as stated in SDG 11, which is Sustainable Cities and Communities. The piping effect. Water escaping from a pressurized pipe washes away the surrounding fines or soil, known as internal erosion or piping, accelerates the formation of a void in the soil layer. Moving on to the scope of technical explanation, the first one is underground soil erosion and the piping effect. When underground utility pipes develop small cracks or leaks, water escapes under pressure. This water doesn't just sit there, it begins to wash away the soil from the surrounding. As a result, when these particles are removed, a small tunnel called cavity forms in the soil. This is the piping effect, which accelerates the erosion process without any sign appearing on the road surface. So, the second one, water leakage from pipeline drainage. Aging infrastructure in high-density areas like Masjid India often involves pipes that are several decades old. Constant leakage saturates the soil, increasing the pore water pressure. This reduces the effective stress, essentially turning stable soil into a muddy mixture that can no longer support weight. The third one is the formation of underground voids. In a karst environment, there are natural openings in the limestone bedrock. When the soil above becomes saturated and eroded, it begins to migrate or leak into these rocks. The fourth is the heavy traffic and urban load. Jalan Masjid India is a high-traffic pedestrian and commercial zone. The weight of vehicle and building adds constant downward pressure, and the vibration from heavy vehicle act like a hammer, constantly stressing the thinning soil bridge. Now we will watch a short animation on how the sinkhole was formed. So when the water was leaked from the pipe underground, it will wash away the surrounding soil, or in this case the limestone, and the cavity under the road surface will be formed. After that, the upper layer of the road surface will no longer have the capacity to bear the loading and it will collapse, hence the sinkhole was formed. Thank you very much. Parts, I will explain how the Jalan Masjid India Sinkhole incident affected society and why it's become more than just a road failure. When a sinkhole suddenly appears in the middle of the urban road, the first concern is not the damaged road, but the people around it. Pedestrians, road users, workers, visitors, and nearby business owners were all exposed to a sudden public safety risk. This shows that infrastructure failure can immediately become a human safety issue. Second, impact is the traffic disruptions. Once the area was closed and diverted, movement around the city became more difficult. People face congestions, delay, and limited access to the nearby premises. The third impact is business interruptions. For shops around the affected area, restricted access means fewer customers, reduced activity, and possible loss of daily incomes. Finally, the incident created a public fear. A sinkhole in the heart of the city can make people questioning the safety of the roads and underground infrastructures. The incident also highlight the ethical responsibility of civil engineering. In civil engineering, the most important duty is to protect public health and safety. Engineer must make decisions based on the risk, evidence, and responsibility, not simply based on cost, speed, or pressure to reopen the road quickly. That is why regular inspection is important. Road, drainage system, underground utilities, and ground condition must be checked before defect become dangerous. A sinkhole may look sudden from the surface, but in many cases, the problem develops underground over time. If a potential hazard is found, engineer must report it honestly and clearly to the authorities. Transparency is a part of the professional ethics because incomplete or delayed information can put the public at a greater risk. Most importantly, engineer must act early. This may include monitoring, temporary closure, repair works, or preventive maintenance. The strongest engineer response is not only reacting after failure happen, but preventing harms before it's occurred. All issues cannot be prevented by engineers alone. It's required coordinated action from all stakeholders. First, the BKL or the local authority plays the role of coordinating inspections, road closure, traffic diversion, and public communications. Engineers are responsible for assessing ground stability, investigating the cause, and recommending proper repair and monitoring. Utility and sewerage agency also play an important role because sinkholes may link to underground pipes, drains, leaks, or void. Therefore, they must inspect and repair underground service before the problems become worse. Emergency responders are needed to secure the sites, control access, and protect the public during the incidents. At the same time, the public and nearby business must follow safety instructions, report warning signs, and avoid unsafe areas.
Hi, Firdaus here, and now I will talk about regulations. Malaysia regulation plays an important role in preventing ground subsidence and sinkhole incident. The Street Drainage and Building Act 1974 give local authorities such as DBKL the responsibility to maintain drainage system and underground infrastructure. The Uniform Building Bylaw 1984 ensure that buildings are designed safely with proper foundation and site investigation. Meanwhile, OSHA 1994 protect worker and the public through hazard identification and risk control during construction. The maintenance activity. Therefore, strong regulatory compliance is essential, improving infrastructure safety, reduce failure risk, and create a safer urban environment. Okay, for the sustainable engineering solution, the ground penetrating radar or GPR helps engineers detect underground void, leaking pipe, and weak soil zone before they develop into serious ground subsidence or sinkhole incident. This technology is non-destructive, meaning inspection can be carried out without damaging road or existing infrastructure, making it suitable for dense urban area. In addition, GPR provide fast and accurate underground data, helping reduce inspection time, maintenance costs, and improve overall public safety.
Another advanced sustainable engineering solution is the implementation of BIM and smart monitoring system. BIM or Building Information Modeling provide accurate 3D infrastructure models and integrated data for better planning and analysis. At the same time, smart sensor continuously monitor ground movement settlement and underground condition in real time. This system also provides early warning alerts, allowing engineers to detect risk earlier and take preventive action before sinkhole or infrastructure failure occur. Alright, for the last sustainable engineering solution is pipeline inspection and replacement. Regular inspection helps engineers detect cracks, corrosion and hidden pipe leakage before serious damage occur. Aging underground pipelines should also be replaced to reduce the risk of underground collapse and infrastructure failure. In addition, leaking pipes can gradually wash away surrounding soil and create underground void that may lead to sinkhole. Therefore, proper maintenance and replacement programs are essential to improve infrastructure reliability, public safety and long-term urban sustainability. Next, I will pass to Iman Zuhairi.
Although technologies such as GPR and smart monitoring system can help reduce sinkhole risk, the long-term impacts of this incident must also be considered. The Jalan Masjid India sinkhole incident caused not only physical damage but also economic, environmental and social impacts. Economically, repair and rehabilitation works require high costs for road reconstructions and underground utility replacement. Business around the area were also affected due to road closures and reduced public activity. Environmentally, reconstruction works can increase construction waste, material usage and carbon emissions. Socially, the incident created fear among the public because sinkholes can happen suddenly in busy urban areas, reducing public confidence in infrastructure safety. Study shows that sudden ground collapse can damage transportation system, buildings and even threaten human lives if preventive actions are not taken. Research also shows that preventive maintenance is more sustainable compared to reactive repair works because it can reduce failure risk, extend infrastructure service life, and lower long-term maintenance costs. As shown in this comparison, reactive repair only happens after failure occurs, while preventive maintenance focuses on early risk detection and planned maintenance. This shows that engineers should not wait for failures to happen before taking actions. In the future, cities should move towards preventive engineering system through smart monitoring technologies and sustainable infrastructure planning. Technologies such as IoT sensors, AI system, and real-time monitoring can help engineers detect underground problems earlier and reduce future risks. Regular inspection and proper underground utility management are also important to improve long-term infrastructure safety. These approaches also support SDG 12, which focuses on responsible consumption and sustainable infrastructure management by reducing unnecessary repair works and material waste. Therefore, preventive engineering is important to help create safer, smarter, and more sustainable cities. In conclusion, the Jalan Masjid India sinkhole incident reminds us that hidden underground failures can become major public safety risks if infrastructure systems are not properly maintained. Preventive maintenance and smart monitoring systems are important to reduce future risks and improve infrastructure safety. As future civil engineers, our responsibility is not only to build infrastructure but also to protect society through safe, sustainable and preventive engineering practices. As stated by Henry Petrosky, engineering is achieving function while avoiding failure. Thank you.